Good evening, everyone. Thank you for joining us tonight. Welcome to the Avexia webinar series. Our topic for tonight's special webinar is Metabolomix, Clinical Utility, Patient Convenience. My name is Joanne Iverson. I'm the Director of Client Relations for Avexia Diagnostics and will be your host for this evening. Tonight, I have the distinct pleasure of being joined by an exciting guest, Dr. Stephen Goldman, who will be our presenter for this webinar. Dr. Goldman earned his Bachelor of Science degree from the University of Massachusetts. He received a Doctorate of Chiropractic from Cleveland Chiropractic College, where he also served as a member of the faculty. Following 25 years of family practice in Los Angeles, where he worked largely with athletes and patients concerned with optimal health, Dr. Goldman relocated to Asheville and joined the medical education team at Genova Diagnostics. As a medical education specialist, Dr. Goldman provides educational support to physicians through individual and group consultations. He also creates educational support materials designed for practitioners. Joining Dr. Goldman tonight will be Dr. Wayne Sedano, our Director of Clinical Support and Education at Avexia Diagnostics. Additionally, Dr. Sedano is the Director of Integrative Medicine Education for the College of Integrative Medicine and lectures and teaches internationally. Before we begin, just a bit of housekeeping. We encourage participation, so if you have a question, you may submit your questions in the questions field in the right-hand area of the interface. We will answer submitted questions towards the end of this presentation. If your questions are not answered this evening, you will surely receive an answer by email within a day or two. If you would like a copy of the PowerPoint presentation, please request it in the question and answers box, and we will get that over to you this evening. Without further delay, I will now turn the webinar over to Dr. Goldman.
Hi, everybody. I am Steve Goldman, part of the medical education team at Genova Diagnostics, and I'm very happy to be with you here tonight going through one of my favorite tests of the many that we offer at Genova, which is the Metabolomix Plus. And so before we get started, let's take a look at some of the objectives of this presentation. It will begin with a discussion of the history of the metabolomics. And it's kind of an interesting history that we'll get to. It really was put together for a very specific purpose. And then we're going to distinguish functional versus direct measure assessment. This is a question that comes up all the time in terms of where are these recommendations coming from? And understanding functional versus direct measure assessment is a key to understanding the answer to that question. We're going to highlight the enhanced clinical utility of the Metabolomix Plus. It's a very comprehensive test. It provides great information and direction in terms of nutrient cofactor needs and a wide range of different possibilities in terms of follow-up for the clinician. And then we'll review each section of the profile. So we'll go through each page, each section, and there are add-on options as well. In fact, the Metabolomix, as we'll see, has a basic framework, and then on top of that, the Plus, you can add other portions to it. And then we're going to just spend a little bit of time contrasting the NutriVal with the Metabolomix Plus, and that's because they're both really seeking very similar information in somewhat different ways and some similar, and we often get asked to contrast the difference between the two, and when I can, I will bring that to your attention. And then I have a case study utilizing the Metabolomix Plus at the end to demonstrate how one might utilize it in a clinical setting. So let's take a look at some of these. As far as the test itself, it begins with this front page, and we'll go through all of these individually. But this is our front page, and it gives you insight into the various functional imbalances that may be occurring. So immediately on the first page, you get a sense of what is the test telling us. And that's an algorithm that's utilized for that. And then we have, once we understand what the highlights are, what are the actual recommendations that are made by the algorithm? And then, let's see if that'll work. There we go. And then the interpretation at a glance section. Once you have a sense of what are the highlights, what are the recommendations? The next task at hand really is, how do I explain this to my patient in a way that they can truly understand and utilize? And there are 3 pages to that interpretation at a glance. And again, we'll look at that format as we move through these slides. Once we have the interpretation at a glance and an understanding, we start the organic acid section. And that begins with a Krebs cycle, citric acid cycle pathway chart. This is how I always determine in a consult the interest of the doctor. Some doctors get to this page and I can feel them go, oh, please, don't make me go through the Krebs cycle. It brings back memories. And others can't wait to go through this. I know all of you are here tonight because you can't wait, and we will. And then, of course, the organic acids. There are a couple of pages of organic acids, and we'll go through each section to understand how to interpret these and the clinical value of the organic acids. And this would be the second page of the organic acids. And then we have the amino acids. The Metabolomix Plus utilizes urine mostly. And so for the organic acids and the amino acids, we're looking at first morning void collection of urine. Now, this is an optional add-on. We've already kind of gone through the fundamental structure of the organic acids, the amino acids that include a couple of ox stress markers. That's the backbone of it. Then there's an optional add-on of essential and metabolic fatty acids through bloodspot that the patient can do at home. And also the option of through urine, a comprehensive urine elements profile, which, as you can see, is a pretty extensive list of toxics and nutrients. And by the way, on top of that, there are 4 add-on SNPs, single nucleotide polymorphisms, from a buccal sampling that we'll take a look at as well. So that's really the test itself, the optional add-ons. We'll look at all of those individually. But I first, as far as the principle of things, had mentioned functional versus direct measure. So we talk often about functional measure. Here we have, it's an assessment or recommendations for nutrients based on analytes measured that require those specific nutrients as cofactors. So in other words, when we're looking at a functional view of a need for folate, we look at an organic acid called FIGLU, formiminoglutamic acid. And if that's elevated, it speaks to functionally that there is a need for folate, and the algorithm will take that into consideration. And the concept is, with this organic acid, this enzyme, glutamate formiminotransferase, requires folate. With adequate folate as a cofactor, FIGLU will be converted to glutamic acid. So that if we see an elevation of FIGLU, that implies that perhaps the cofactor of folate is what's needed to upregulate that pathway. That would be a functional recommendation for folate, one of many, which we don't use just one marker for that, but that would be one of the things the algorithm is utilizing in its recommendation. Whereas for the direct measure, it's what most people are have more experience with, a direct measure of the nutrient. So if you take a blood level of folate and then assess that based on a specific screen cohort. So I could have 100 different people, screen it down to 95. That's my reference range. We draw blood and we see what's the highest bump, that one standard deviation. And from that, we compare the blood measure of folate. And that would be a direct measure of folate against a screened population, as opposed to functional, utilizing nutrient cofactor needs that show up on the test. So 2 different ways of doing this, both, of course, well-researched and utilized clinically. So we can move on now to the metabolomics background, which is very interesting, in my opinion, because it really began with COVID. I know I was working from home, and a lot of patients were hesitant, at least, to leave home and seek an outside phlebotomist and take a blood draw to do a NutriVal, which always involves a blood draw. One of the major differences in what's on the test, what's available. So the Metabolomix Plus was really designed for those patients to be able to do all the collection themselves at home and ship the kit, and therefore get a report without having to leave their home and get a blood draw. So that's really the beginning of it, and why, when you look at the differences with the NutriVal, and when you look at what's available on a Metabolomix, you'll note that all of these are things that we can do at home, particularly organic acids, first morning urine, void urine, amino acids, and the ox stress markers. Again, as I mentioned earlier, there is a blood spot for essential metabolic fatty acids, a buccal swab for SNPs, and also urine for the comprehensive urine elements profile. So with all of those opportunities, we can really build a test that provides a wealth of clinically useful information, and the patient can do that all in their home and get it done without a phlebotomist. The NutriVal, on the other hand, does require blood samples, and that determines really a lot of the difference that we'll note between the two samples, the two test profiles. So again, the basic formats for the Metabolomix Plus, it begins with the organic acids from first morning void, and you see this first page, and then the amino acids, and this is what that amino acids page is going to look like, and we'll look at these findings and get a feeling for how to look at these and garner information, and then the oxidative stress markers, which are lipid peroxides and 8-OHDG, 8-hydroxydeoxyguanosine. So this is all the organic acids, including the oxidative stress and the amino acids, the basic test. Again, the add-ons are the essential metabolic fatty acids from bloodspot, literally a pinprick and putting that on a surface that's part of the kit so that we can measure the essential metabolic fatty acids. The comprehensive urine elements profile, and by the way, you have an option of doing the comprehensive urine elements profile or a toxic elements profile, and the difference is that for the comprehensive, it's both the toxic elements, as you see listed here, and the nutrient elements. You can choose to do just a toxic elements clearance profile, which would just be these toxic elements and not include the nutrient elements. That's up to you. It is an add-on option. And then we have these SNPs, the buccal swabs, MTHFR and COMT, for those of you who work a lot in terms of methylation and methylation support. These are two enzymes involved in methylation. MTHFR, the folate cycle, COMT, a methyltransferase enzyme, a real key methyltransferase enzyme. TNF alpha, a cytokine, a very pro-inflammatory cytokine, and apolipoprotein E in terms of the metabolism of cholesterol and how one tends to utilize cholesterol. So those are all the different elements that are available. Now, this little test pearl is that be aware that when you run this test, towards the back under commentary, there will be a link, www.gdx.net NutriVal guide. The NutriVal and Metabolomix guide are one and the same. And when you pull that up, you could be looking at the test, hit that link when you're on your computer. This guide, this support guide, goes through every single marker on the test, every organic acid, every amino acid, every toxic, every nutrient. It's all very well written up in the support guide with references all over at the end of each chapter. So let's take a look at some of the results, overview and functional imbalances. This is, again, the front page. You have these icons here, they're color coded. And then you have these functional imbalance scores, the various pillars. So you can see there, oxidative stress, mitochondrial dysfunction, omega imbalance, toxic exposure, methylation imbalance. And these columns are based on the various markers that we see underneath the finding. So, for example, anything 0 to 4 is a minimal need for support in green. 5 to 7, yellow, moderate need for support. 8 to 10, red, high need for support. And so right away, when I look at these, and this is based on the algorithm, I can see, wow, omega imbalance is key here. Now, if you recall, the essential metabolic fatty acids is an add-on. So if you do the essential metabolic fatty acids section, you'll have this pillar. If you don't, this won't be there. But if you order that blood spot, you'll get all of these markers as part of that test. And so I see here a high need in red. And you might wonder, well, how'd you come up with that? How did the algorithm determine an 8 in red? All of the various markers listed here are the markers specifically utilized by the algorithm to come up with this 8 in red. Wherever you see on this test a green circle, that indicates that that marker or ratio measured comfortably within the reference range. Wherever you see a yellow triangle, that means that the marker is either high or low, but still within the reference range. So this arrow pointing down tells me the omega-3 index was low within the reference range. And wherever you see red, high or low, but outside the reference range. So you can always look at this and have a sense of what skewed us to an 8 in red, or a toxic exposure of 7 in yellow, or a moderate oxidative stress need. It's all there. So that if you run this test again down the road with this patient and follow up, you immediately have a scorecard of what it was and what it is currently, and immediately get a sense of what markers were responsible for that score. Now, once the patient has a sense of these various areas of concern, the next thing you want them to be aware of is, well, what am I going to do about it? And that's what the nutrient need overview, page 2, is all about. So it's got all these different areas, categories: antioxidants, B vitamins, minerals, essential fatty acids, GI support, and at the bottom, amino acids. And it has this color coding that is, the green would mean a low need for support. Yellow would mean a moderate need for support. Red would indicate a high need for support. Now, to the right of that, this DRI is basically your government minimal standard, how much vitamin C to prevent scurvy number. It's really just there to give you a sense of proportion. If I am being transparent, I don't pay that much mind. What I do pay a lot of mind to is the suggested recommendations column, color-coded green, yellow, and red, and that is what the algorithm is recommending. Now, algorithms are just mathematical tools. They are wonderful tools, but they're not the end all. You are face-to-face with the patient. So you might see an alpha lipoic acid at 200 milligrams and go, you know, a high need, I agree, but I think this patient needs 500 milligrams. That's fine. That's why we have the provider recommendations column. That's going to be your opportunity to put in what you think it would be best for the patient. And then we have at the bottom the GI support with digestive support, microbiome support, and we have the amino acids listed as well. Now, the amino acids, to me, you know, when you look at those, they give you, the zeros indicate, based on the direct measure of the amino acids, that the algorithm has determined you're in the reference range far enough that you don't need supplementation. Any number there would be a recommendation in milligrams per day. But when I speak and organize this test, interpret this test, I always tell practitioners, let's hold off until we get to the amino acids page, because sometimes there are patterns that emerge that I think are significantly more interesting than just, oh, you may need a little arginine, it was low, and so you need, 51 milligrams. Patterns, I think, really tell the story. And we'll go through the patterns that I'm describing when we get to the amino acids. Now, the next stage, when we talk about the interpretation at a glance, this is how we educate the patient as to what's going on here. What is the meaning of this? How do I interpret it? How do I use it? So if we look at the page 3, and this is a section of 3 pages, this is the antioxidant needs for the patient. If we look at vitamin A, we can see that the rating by the algorithm for the function lead for vitamin A was a 4, green. So a pretty low minimal need. The green dot tells us what is vitamin A. The blue dot, I should say. The green dot, I got thrown. Something popped up on my screen. I'm like a dog that sees a squirrel run across their screen. The blue dot is what is vitamin A. The green dot is how may have I become deficient? The purple dot is what might I see clinically as a result? And my favorite that I think is really useful and overlooked, the red dot, how do I get this from food sources? And there's a key at the bottom of each page in this section if you forget the color code. So it continues on. This is the antioxidant page, and it's a great tool in explaining the results of the test to the patient. And as I said, I think foods are so important as well as supplementation. And when I'm asked, I always say, get back to that interpretation at a glance, and there's a listing there for you. Now, when I look at the organic acids, I always want to have a sense when I look at any of these pages, any of this data, which is what does it mean? Why am I looking at this? You know, people interpret organic acids often, but I always want to know why. What is it exactly? You know, organic acids are not nutrients. Organic acids are made from nutrients. Nutrients like flavonoids, amino acids that are going to go through the body, all over the body, down intermediary metabolic pathways. And these metabolic pathways along the way are going to change the precursor nutrients into metabolic end products. So that when it comes to the malabsorption dysbiosis, for example, you're going to have things like phenylalanine and flavonoids, and they go down pathways in the gut, and they're going to encounter anaerobic bacteria that are going to change them into intermediary metabolites, which is fancy for organic acids. So we're looking at the organic acid end products, metabolites of pathways, to try to get a sense of those specific pathways. And if a number of these pathways are pointing in the same direction, that gives us some guidance as to areas of possible concern. So I think of the organic acids as my scouting report, because look at all the different headlines and categories that I can get some sense of: malabsorption dysbiosis, vitamin markers, cellular energy and mitochondrial markers, neurotransmitter metabolites, toxins and detox markers, and there's even more on the next page. So that's why we look at the organic acids. Now, this page, and we'll get back to that page that I just looked at, but this is actually page 7. We were just looking at page 8. But if I go back to page 7, this is the oxidative stress and the mitochondrial dysfunction page. And again, I find it fascinating because what we're looking at here is a pathway chart. And so if you look at this, you'll see what we did was we laid down a pathway chart of the Krebs cycle, right? And then we superimposed organic acids that are listed on page 8, and we placed them in their proper order. And we are, in doing that, looking for any imbalances that stand out. Because if we find imbalances, then we can find nutrient cofactors specific to those imbalances and maybe provide better balance to the function of the Krebs cycle. That's why we're doing this. So we start off with these precursors. So we have proteins. These are macronutrients. Proteins as amino acids. Carbohydrates through glycolysis. Remember, carbohydrates are our preferred fuel through glycolysis, with magnesium as a cofactor, making pyruvic and lactic acid. And then we have fats as fatty acids. And we want fatty acids to go through beta oxidation inside the mitochondria. That's the fuel source of fatty acids that we want. All of those will combine and bring us to acetyl-CoA, and then the fatty acids which penetrate the mitochondria hopefully will do beta oxidation through what's called the carnitine shuttle mechanism. So just to show you this, another very, I think, fascinating thing. Fats as fatty acids are floating around in the cytoplasm, as are the mitochondria. The mitochondria have a wall, basically, a membrane surrounding it. The fatty acids have to penetrate that. They have to get inside the mitochondria in order to beta oxidize the way you want them to. And they do that through, as I said, this carnitine shuttle. So they get aboard the shuttle, they penetrate the mitochondria, they beta oxidize. If there's a problem, if you don't have the nutrient cofactors and the shuttle's down-regulated, if you have a ketogenic diet or just a high-fat diet and it's overwhelmed, you will find that the fatty acids will just shrug their shoulders, and yes, they have shoulders, and they will say, heck with this, I'm just going to start oxidizing here where I'm floating in the cytoplasm. That's called omega oxidation. And omega oxidation, and you see that here, has byproducts of adipic and suberik acid. So when you see an elevation of either adipic or suberik acid, that tells you, that clues you in that, hey, that carnitine shuttle is overwhelmed. And then you have to come up with an explanation. Do they need the cofactors? Magnesium, B2, I would add L-carnitine. I would pencil that in there as well. If your patient's on a ketogenic diet, you might expect that. But I would still give the cofactors so that they can get the most from those fats through beta oxidation. Now, acetyl-CoA is going to fuel the citric acid cycle, but it can also deviate to ketogenesis and produce a ketone body called beta-hydroxybutyric acid. We see it here, yellow with an arrow pointing up. So it's in the reference range, but a little bit high. It could be from a high-fat diet. It could be from a low-carb diet. It could be some catabolic issue where they can't utilize their sugars well. Maybe they're diabetic or pre-diabetic, and therefore they're breaking down fats for energy. I'm often asked, well, if you have a high beta-hydroxybutyric acid and they're on a ketone keto diet, is that a problem? And I would say no. That's what you're kind of aiming for. Now, and that indicates that that's what's happening. I would still support the carnitine shuttle. And then acetyl-CoA itself goes to citric acid. Now, in the citric acid cycle, most people believe that the citric acid cycle is where the ATP, the energy, is made, but really only a handful of ATP is made here. Perhaps the most important byproduct is going to be NADH with its hydrogen ion and FADH. And so they drive this electron transport chain. These free radicals remind you how intense this is, how volatile. But at the end, you're going to make somewhere between 32 and 36 ATP molecules. So also, in the citric acid cycle, we can see iron and glutathione, B3, magnesium, manganese. So as this moves forward, if it's not moving forward, you can look at the various cofactors to get a sense of nutrient cofactor needs to drive the cycle. And then since the electron transport chain has so much ox stress, they decided to list the oxidative stress markers here in their color coding. We'll see them measured later on page 9. Lipid peroxides here are in green, but lipid peroxides, when they're high, represent measurable oxidative stress damage. Same with 8-OHDG to DNA, and we'll look at that a little further. Be aware that the CoQ10 and glutathione are here, but they're in black. That's to remind you that they're not measured on this test because the glutathione and CoQ10 come from a blood draw. So they'll be measured on a NutriBal because of the blood draw. But here we do get the lipid peroxides and 8-OHDG as our ox stress markers. Now, going back to the organic acids, and these are the 2 pages. And so we're going to look at these different sections of the organic acids. So they start here, and you see right up here the malabsorption and dysbiosis markers. And so there they are, up close and personal. And so these look pretty good. But we do know, again, with malabsorption and dysbiosis, we start with precursors. Precursors like nutrients, quercetin, bioflavonoids, berries, cherries, wine, chocolate, amino acids, and they go through these pathways. And if there's an issue with their absorption, then you have an increase in the organic acid. Or if there is an imbalance in the anaerobes converting the nutrients into the organic acids, that can affect it. But also, you can have issue with common dietary sources. So this is a chart that is in the guide. The first chapter of the support guide is organic acids. Everything I'm showing you is individually discussed and described there. But on page 6 of that, there's a wonderful table for the various malabsorption and dysbiosis markers and common dietary sources. So if you have a high indoleacetic acid, that could be because tryptophan is being poorly absorbed, or there's some issue with the bacteria, the anaerobes, but it can also be a high tryptophan intake, like green and black tea. So it's always, I think, beneficial to have this handy when you're interpreting this. Now, as far as the yeast and fungal dysbiosis markers you see down here, the diarabinitol, we used to use arabinose, which is a sugar, but we switched to diarabinitol. And here's our dirty little secret. It's not an organic acid. It ends in OL. It's an alcohol. So the thinking there is, in the presence of Candida species, and you see the different albicans, tropicalis, paraciliosis, when they encounter the sugar arabinose, that's a sugar, they will convert that, ferment that into the alcohol diarabinitol. So in the literature, it's described that a high diarabinitol can point in the direction of Candida species. Now, for this whole section, but certainly for yeast, a stool analysis is your gold standard. Here you're basically taking a data point and looking at what it may be pointing to. On a stool analysis, you're actually culturing, in a mycology, you have a culture of Candida that you can actually see and measure and get sensitivities to. So if I saw a high diarabinitol, that would certainly get my attention, especially based on the clinical presentation. But the gold standard for this section is certainly going to be a stool analysis. And we looked at this table, which I love. Now, another section here is the vitamin markers. So these markers contribute to the functional evaluation for B vitamins. Remember, I said earlier, you have this list here of organic acids. They require specific B vitamin cofactors in order to be move along their pathways, to be metabolized. If those specific B vitamin cofactors are inadequately present, functionally low, then the organic acids will accumulate in the blood and get dumped into the urine in higher and higher concentrations. So that's what we're looking through the algorithm. So this isovalerioglycine is getting a little high, may have some leverage around B2. We talked about fig glue and folate, which always makes me think about methylation as well. So you have these different subheaders in gray, different categories, and you see there are various cofactors that are needed in each of them, and the algorithm will take them all into account. And you can memorize which ones are which vitamins, which B vitamins, and that's fine, but you don't have to, because the algorithm is going to take those into account in their recommendations on page 2 for B vitamin. So, you know, I mentioned the fig glue earlier, and this would be for the methylmalonic acid. How is that functionally measured? Well, you have this methylmalonyl-CoA. It needs this MMA mutase enzyme to convert it into succinic acid. What cofactor is required? B12. So if you don't have enough B12, the methylmalonyl-CoA is not going to make that move, and it will instead produce more methylmalonic acid. So an elevation of methylmalonic acid has an association with B12. And you know, we already looked at this fig glue diagram. Same thing with these branched chain amino acids that convert into these organic acids. And then they go through an enzyme that converts them into the Krebs cycle as acetyl-CoA and succinic acid. Part of the proteins to amino acids at the top right of the page that we looked at with the cycle diagram. And so these are the cofactors that are needed to make sure that this enzyme is doing its job. So elevations of these organic acids, a backup of them, speak to a need functionally for those B vitamins. Now, there are these neurotransmitter metabolites, and I find these really fascinating. And if you look at these kynurenine markers, you see I listed it here, but the kynurenine pathway, I think, is very underestimated and not described much. And I know this is true. People aren't interested. When I'm at a cocktail party and I start talking about the kynurenine pathway, I find myself alone with a cocktail. But it's important because in the liver, Tryptophan, for the most part, is metabolized. It's also making serotonin and other amino acid, combined with them to make proteins. But much about tryptophan is going to be metabolized in the liver through the kynurenine pathway. And so the first step is that the tryptophan will convert into kynurenic acid. And all of these require B6. So this high kynurenic acid will trigger some B6 need. But the good news is kynurenic acid is protective against oxidative stress, systemic inflammation. But further downstream, the tryptophan starts to make quinolinic acid. Quinolinic acid is a neurotoxic. It's excitatory to the nervous system. Over time, it can create brain cell damage and cognitive issues. It is associated with systemic inflammation and oxidative stress. So when we look at the kynurenic-quinolinic ratio, we're asking the question, is my patient making more of the protective kynurenic acid or the neurotoxic quinolinic? So we like a high ratio because that tells us more of the protective. If it were in the red, more quinolinic, then we have a lot of work to do to try to address any oxidative stress, any inflammatory toxic mold exposure to tamp down the production of quinolinic acid. Xanthoranic acid is an offshoot of this pathway and has an association as well when elevated with systemic inflammation. We have the catecholamines as well, which is the pathway. Again, these all begin with nutrients. Again, it is phenylalanine, which is going to tyrosine that makes dopamine. And dopamine in the adrenal medulla is going to make be methylated into homovinylic acid, but then the dopamine will make epinephrine, norepinephrine, and then these metabolites, the vinylmandelic and the 3-methyl-4-hydroxyphenylglycol. It looks very balanced. If not, there are nutrient recommendations. And then the serotonin pathway, which is tryptophan converting into 5-hydroxytryptophan, which you may be giving to your patients to help them sleep. 5-hydroxytryptophan converts into serotonin. 95% of that serotonin is manufactured in the gut for improved gut motility. Only about 5% in the brain for mood. So when you're seeing this 5-hydroxyindoleacetic acid, organic acid, end product metabolite of serotonin, if it's elevated, it could be your patient is on a high tryptophan diet. It could be that your patient is taking 5-hydroxytryptophan for sleep. Patients on SSRIs, which alter the metabolism of serotonin, tend to elevate this metabolite. And there are medications, Valium, naproxen, Tylenol, that can have an impact. But if none of that seems to make sense for your patient, since 95% of this metabolite is being made in the gut, it would point to a need to address the patient's gut issues. Now, this is the, and you might want to look at this later, the kynurenine pathway that I described, very B6 dependent. This is the catecholamine, the phenylalanine to tyrosine, and the production of vinylmandelic acid. So this is really what I was just describing. Here's the dopamine. So if you wanted to really check out the pathway charts, these are in the guide, by the way, but I thought you might want to see them. And then another section is the toxin and detoxification markers. Pyroglutamic acid is involved in glutathione recycling. You know, you often have this debate. My patient needs glutathione. Do I give them the precursors and they make it themselves? Or do I give them glutathione? A lot of the management of making that glutathione comes from pyroglutamic acid. When I see elevations, sometimes I see it low, but any change high or low of pyroglutamic acid, I start wondering about my patient's capacity to maintain adequate glutathione. The alpha-ketophenylacetic acid comes from styrene, styrofoam, plastic PVC piping. Alpha-hydroxy isobutyric acid is from MTBE. MTBE is an old gasoline additive. I'll talk about that in a second. The orotic acid is very often high or low based on, especially elevated, some sort of possible need to support liver function and urea cycle function. The MTBE is an old gasoline additive. In the 1990s, the EPA came out with its first gasoline emission standards. And in order to address that, the oil companies dumped MTBE into the gasoline, which, by the way, was very effective. It really lowered those emissions until they realized that MTBE itself is a toxin. And it gets stored in water a lot for a long time in the environment. So well water is your first concern, but even patients who have a plant-based diet, if those plants are watered and grown in soil with MTBE contamination, that's a problem. The good news about the styrene and MTBE is that they're both water soluble. So they're not getting stored in adipose tissue, but you do want to find where the exposure is coming from. Now, we also have these oxalate markers, and these were added on later on when we got a lot of feedback. People wanted oxalic acid because an elevation of oxalic acid is tied to a possibility of a greater risk of kidney stone formation. But glyceric acid can be problematic. You see it when there's a need for magnesium and B3. It comes from serine. If you have an amino acid serine that's high, you're likely to have a high glyceric acid. There's some literature that says that even fructose can elevate it. Interestingly, there's an association in the literature of glyceric acid with rheumatoid arthritis and bipolar patients and schizophrenic patients. And I have to say, and this is not a scientific thing to say, but when I have consults with doctors, when I mention bipolar, I'm surprised at how often they go, oh yeah, this is a bipolar patient. So, I don't know the math and the statistics of it, but that is something that it's tied to in the literature as well. Here are the oxalates and their pathway. So there's the serine to glyceric acid. Now, if your patient is taking collagen supplement, and I think even bone broth, you might see a higher oxalic and glycolic acid as well. The collagen increases in its turnover. High oxalic acid and glycolic acid may indicate a need for B6 as well. The glycolic acid also depends on glutathione, the glyoxyl to glycolic acid. So a low level could be a glutathione need. Now, I mentioned the oxidative stress markers previously, the lipid peroxides, which provide measurable levels of damage to lipids like cell membranes, but also the 8-OHDG, 8-hydroxydeoxyguanosine, which measures in the cell nucleus where free radicals can create DNA damage. So in the yellow or red, they're going to drive an antioxidant recommendation by the algorithm. Here, they both look very good. So our key takeaways so far: organic acids are not nutrients. They are the byproducts of metabolic pathways that begin with nutrient precursors, amino acid, flavonoids. Patterns that emerge from organic acid findings can provide insight into various areas of interest. My scouting report: organic acids act as a scouting report. How did they know I was going to say that? They are a key component in determining vitamin algorithm functional recommendations. So what about the amino acids? I mentioned earlier that I like to look for patterns here. Now, these are first morning void amino acids, which means that you're really looking at a shorter term, a day or two, of how from the food your patient has taken in, they are digesting and absorbing protein. On this test, the Metabolomix Plus, where we're not doing blood draw, this is the only option, first morning void, and it's a good one. The NutriVal has the option of doing it exactly like this, first morning void, or a plasma amino acids as well. So here we're looking at first morning void amino acids. I compare the first morning void versus the plasma, like if you're looking at a morning glucose blood draw versus a hemoglobin A1C. The morning fasting glucose is going to tell you where are you at pretty much right now. The hemoglobin A1C tied to red blood cells, the hemoglobin, gives you more of a wider time frame as to where you are with the glucose. And it's the same with first morning void versus plasma amino acids. But there are patterns that matter. Now, this, as you may recall, was at the bottom of page 2 for the recommendations. The zeros indicate, oh, you're fine, you're within the reference range. This person obviously has a lot of amino acid needs. But again, I like to look at patterns. So I first look at the nutritionally essential amino acids. And when I look at these, I want to see, is there any pattern? They're nutritionally essential, which means that they come from foods. So sometimes it's useful to look at those patterns. So I draw a plumb line, an imaginary plumb line, usually, right down the center and ask myself, is there a pattern? And I think there's a pretty obvious pattern here. Here, in this case, it's left of moderate, a low overall nutritionally essential amino acids pattern. So now I've got a question. Is it low because the patient isn't eating much protein and maybe it's about taking in more protein? Or is it low because the patient is eating protein and not getting much digested and absorbed, not getting much from that, that level of protein intake? So the right side of the page gives me some information. So first I check the urea level. In this case, it's really low. Now remember, when you eat a protein, you have to detoxify the ammonia. You do that in the liver in the urea cycle. So very often, assuming the urea cycle is functioning well, liver function is good, very often the urea gives you a good insight into the amount of protein. The high urea patient tends to have a higher protein intake, the low, just the opposite. And then I look at the dietary peptide related markers. These can give me really good information around the dietary intake of protein. So I'll just scroll those down. So anserine comes from fish, fowl, and meat. It's usually low on this test because it tends to convert into 1-methylhistidine. That also comes from fish, fowl, and meat, but can also be high when there's dysbiosis. But in this case, they're low as well. Carnosine tends to come from consumption of red meat. 3-methylhistidine comes from the breakdown of skeletal muscle, the actin and myosin fibers. Excuse me. So if your patient is catabolic, maybe they're pumping iron a lot and tearing down and replenishing muscle, maybe they have a catabolic muscle wasting issue, it'll go up. But what about your patient that eats a lot of red meat? There's a lot of those fibers there as well. And then beta-alanine tends to reflect the anserine and carnosine. And by the way, this is kind of what a vegan looks like on this test. Really low, because those aren't the sources, and even a vegetarian to some extent, those are not the sources of protein that they typically do. But a vegan or vegetarian, even if they're low in these, doesn't have to be low in their essential amino acids pattern. They just need to adjust to other sources. But in this case, I look at a very low pattern of amino acids from the diet, and it looks like on the right side of the page with the urea and the dietary peptide related markers, this patient is just not getting protein. And so rather than say, oh, here are the 4 ones that really need supplementation, I have a different perspective because I looked at these patterns. I'm also, by the way, going to check the patterns from the essential versus the non-essential. If you have really low essentials, you know, here actually the non-essentials are a bit higher. So at least perhaps they're converting their essentials into non-essentials reasonably well. More often, I tend to see where you have a drop-off where the essentials look pretty good and then the non-essentials are really low. That tells me that the conversion is problematic. And for that, I think about magnesium and B6 needs. Key takeaways: the protein patterns can be useful, as useful, if not more useful, in designing a treatment protocol for amino acids. First morning void reflect a window of protein exposure up to approximately a couple of days. The Metabolomix Plus only measures first morning void amino acid levels. The NutriVal also has the option of the plasma amino acids. And then the add-ons. We have the essential metabolic fatty acids from the bloodspot, and that's going to give us our omega-3s. And there is a way of calculating how well they're doing. Here, just eyeballing it, they look problematic. But there is a calculation that involves the EPA and DHA. It's called the omega-3 index. Anything under 4 is considered a strong need for omega-3s. In the literature, 8 to 10 is typically what you're shooting for. The omega-9s, which come from olive oil, for example, olives, The saturated fatty acids, I generally look at the bottom at the overall percent, the 42.3. The guide lists each of these individually for more information. The omega-6s to me are very important because you have the linoleic, which is low here, and that needs to convert to the GLA, which is low here. And you want GLA because that converts to DGLA and then arachidonic acid. Most people are concerned with arachidonic acid elevations like this because that creates a cascade of inflammation. But most people overlook the DGLA as a strong anti-inflammatory. I want that higher, but there's no supplement for it. I'm dependent on the conversion of the GLA to the DGLA. I can add GLA with evening primrose oil, borage oil, blackcurrant. That gives me more GLA to convert. But what about the enzymes? And here we see a chart of the omega-6s. So the linoleic, which was low, this arrow represents the delta-6 desaturase. Here are the cofactors. And by the way, I'm not saying take insulin unless you know they need insulin, but that's just a cofactor. You want to bolster that enzyme to make more GLA, and then the elongase to the DGLA, and you see those cofactors. So in this case, I would probably really look at increasing GLA with evening primrose, borage, blackcurrant, and look at these nutrient cofactors to try to upregulate these enzymes. Now, the other add-on here, I mentioned earlier, the toxic elements or comprehensive urine elements test. So this is what a toxic elements looks like. It's a first morning void. You see all of these toxics. Now, the advantage of using urine here is that you get so many toxics to look at. The disadvantage being that you're looking at a small window in terms of the time frame of exposure. Usually, a couple of weeks or less. A big exception, by the way, is the gadolinium. Gadolinium is in contrast dyes for MRIs, and it seems to stay high in these urine tests for patients for long periods of time if they've had contrast dyes. Now, on the other hand, you can do the comprehensive urine elements profile that has both the toxic elements and all of these nutrients as well. Either of those are tests that you can run as part of the Metabolomix Plus. And then the SNPs. So if we look at these SNPs, remember single nucleotide polymorphisms are very common. They're prevalent, so their penetrance is not as strong. So these are precursors, possibilities, preponderance, but they're not sentences. But in this case, when we look at MTHFR, we see that this positive allele speaks to a downregulation of the MTHFR enzyme. So you want to make sure under clinical management considerations that they have the nutrient B vitamin cofactors, maybe betaine, trimethylglycine. MTHFR prepares the methylfolate to be in the right form so that homocysteine can be methylated back into methionine to keep the methylation cycle going. So this person has a 30 to 40% reduction in MTHFR activity based on that positive allele. COMT, catechol-methyltransferase, here homozygous positive, 2 arrows pointing down. This is a strong 3 to 4-fold reduction in COMT activity. COMT is involved in methylating epinephrine, norepinephrine, serotonin, estrogen metabolites, a real key player in methylation. And then the ApoE is how we regulate cholesterol. Is there a tendency toward making risk-inducing LDL cholesterol or risk-reducing HDL cholesterol? And of course, we've often heard a 4 in one of these alleles, or a 4-4, does increase the risk of Alzheimer's. And then in terms of dementia, the TNF alpha is a cytokine. Cytokines are proteins, most of which are pro-inflammatory. This positive allele tells me that this patient has a predisposition towards making more TNF alpha, which speaks to the possibility of greater strong inflammation. I heard a doctor describe this as the Frankenstein monster of inflammation. I was very pleased because most people would say the Frankenstein, which would be blaming the doctor and not the monster. It is the Frankenstein monster of inflammation, and I believe that to be true. So just a quick look at the Metabolomix versus the NutriVal. Remember, no blood draw required. So the packets come to the patient regardless of the basic Metabolomix Plus, or any of the add-ons, they can do it all at home and send it in. The NutriVal always is going to involve a blood draw as well as urine. Because the Metabolomix doesn't have a blood draw, you're not going to get a direct measure of glutathione or CoQ10, or vitamin D for that matter, where they are measured in the NutriVal, and I believe vitamin D is an add-on option. Toxics and nutrients available as add-on through urine collection, either the toxic elements clearance or the comprehensive urine elements. The toxins and nutrients are through the blood in the NutriVal, but only 5 toxics, only 5 nutrients. So you get a wider time frame of exposure for them, but you get fewer to look at. And then the essential metabolic fatty acids is a blood spot add-on option. It's always part as an RBC test of the NutriVal. So that's the case, everything up into the case study. I will just, I know we're at almost 8 o'clock, and so let me give you this case study to look at and think about. Now, this is a 34-year-old female. She's single. She works in the records department of a local physician. As you all know, what could be more stressful than working for a physician? She's calling it moderately stressful. She never worked in my office. Chief complaint, chronic ongoing fatigue. Wakes up tired every morning. Needs caffeine to get through the workday. Tries to eat healthy, fish and chicken for dinner, but finds sweets helpful for energy, as well as energy drinks and bars. Complains of mild to moderate low back and bilateral knee soreness. Does Zumba class twice a week, but finds it challenging. Complains of postprandial bloating, 1 to 2 bowel movements per day. No meds, no surgical history. So here's her test. So when we look at this, we see that the oxidative stress seems to be the key in terms of a moderate oxidative stress. Moderate dysfunction, mitochondrial dysfunction, toxic exposure, methylation, they look pretty good. Here's the nutrient overview. Look at all these yellows. So a lot of antioxidant needs, a lot of B vitamin needs, but all very moderate. And we see that gut issues also, the moderate need for digestive enzyme support and microbiome. And by the way, the digestive support enzymes is very much from the amino acids that we looked at in those patterns, whereas the microbiome support is more from the organic acids, that first section we looked at of the microbiome. So these were the amino acid recommendations, only the glycine as a need. Here are the organic acids. So let's break that down. So when we look at the malabsorption and dysbiosis, we have a high DHPPA. That comes from the amino acids tyrosine, phenylalanine, tryptophan. And so this could be a problem. Now, as food sources go, whole grains, chocolate, coffee. So there can be some contributing factors. She mentions that she drinks a lot of coffee all day long. That can certainly be part of it, especially when these others look so good. The benzoic acid is very high. And when I see that in isolation where it's that high, any bottled or canned beverage that you consume is likely on the label to have sodium or potassium benzoate as a preservative. And my guess when I see this, especially since hippuric acid has the same food precursors and yet it looks normal, I think I would assume that it's likely that that's coming as a preservative in something that she's drinking from a can or a bottle. A mild arabinitol finding, not that strong. The Krebs cycle. Okay, so some interesting findings, I think, in this Krebs cycle. Here are our macronutrients. Proteins as amino acids, fueling acetyl-CoA. Carbohydrates, our preferred fuel. The pyruvic acid looks pretty good, but look at the lactic acid. Now, the reason I find that interesting is, I mentioned to you how the macronutrients fuel the acetyl-CoA that fuel the citric acid cycle. And that probably the main byproduct of the citric acid cycle, since it doesn't make that much ATP, NADH and FADH, those H's are hydrogen ions. So as they go through this volatile electron transport chain, you have to neutralize those electron hydrogen ions. How do you do it? You do it with oxygen to create water, H2O. If you are lacking enough oxygen to really neutralize those, your body is basically saying, hey, pull your foot off the gas pedal. You're going too fast. We need to slow it down. One of the mechanisms of slowing it down is to start to convert the pyruvic acid more in the direction of the lactic acid. So when you see high lactic acid, very often you're seeing evidence to someone that has trouble with oxygenation, not oxidation, oxygenation, the capacity to make oxygen available. And you can see this in your patients with sleep apnea, COPD, asthma. Maybe they intensively exercise and didn't get a good recovery time. But often sleep apnea patients are going to have high lactic acid here. Now, we also see the fatty acid metabolism. The adipic and suberik, they're a little bit high. They're still in the reference range, but it tells me that maybe that the carnitine shuttle could use a little bit of support. You see magnesium B2, and as I mentioned, I would pencil in carnitine there as well. And the malic acid is high, and all the rest look good. Here's the thing about malic acid high in isolation. You can see that B3 is a cofactor to convert malic acid to oxaloacetic acid, so that's certainly a consideration. But any fruit or vegetable that you are hoping your patient is consuming is likely to have malic acid. So sometimes this pattern of just a high malic acid can be a patient that's eating a lot of fruits and vegetables, which I'm all for. Now, the oxidative stress markers, the lipid peroxides and 8-OHDG, both yellow, elevated. So those are both going to provide some recommendation around antioxidant support when we look at the recommendations on page 2. Now, these vitamin markers, remember these organic acids that have nutrient cofactor B vitamin needs, these all look very good. Really nothing stands out here. But the neurotransmitter metabolites, take a look at that. I'm going to give you a second to look at that. When I look at this, what I'm noticing is the kynurenine pathway. The kynurenic acid looks pretty good, but the quinolinic further downstream, the neurotoxin that is associated with systemic inflammation, oxidative stress, maybe toxic exposure. Look how high that is. Look at that ratio. You know, I should say that all markers here are created equal, but I find the quinolinic acid being high compelling because it can involve so many different systems of oxidative stress and inflammation. So to me, this is the big red flag. And it tells me I have to be really aggressive against inflammation and oxidative stress. The catecholamines look fine. I have no problem with the slight increase in the serotonin marker. So that's the key here for me. And the pathway, if you wanted another look at it. And then the toxin and detox markers, they all look fine. No issues for me there. The oxalate markers, you know, the oxalic acid is a little high. You know, she's relatively young. She's in her 30s. You know, she may find herself having to be careful about kidney stones. The glyceric acid elevation could be from serine. It could be a need for magnesium and B6. You see the oxidative damage actually looks pretty good here. That's odd. It was yellow in the other one, so that must be my error. The amino acid pattern. Essential amino acids look pretty high to me. Moderate plus. Urea is low, indicating low protein intake. So that's interesting too, that the urea is kind of low. And yet, when I look at the dietary peptide-related markers, look how high the 1-methylhistidine is. Now, part of that could be dysbiosis as well as the dietary intake of protein, but the carnosine is pretty moderate. That's kind of a red meat indicator, and the 3-methylhistidine as well, which can be red meat as well as some breakdown of muscle. So she's at least getting a moderate to moderate plus level based on the dietary peptides. I find with the urine, urea can sometimes take a little more time to adjust, and so that may be an issue, but I also want to make sure her liver enzymes are good, that her urea cycle is functioning well. But I think there's every reason to believe she's eating a moderate plus amount of amino acids. She may need some digestive enzyme support to be able to handle it, but at least her nutritionally essential amino acids tend to be moderate and higher. So not a strong finding, but at least a moderate finding for digestive enzyme support. The toxics, we see that there's an arsenic finding. Again, this is a limited window of exposure. It could be in water, soil, rice, vegetables, fish, very common nowadays. And, you know, there are risk factors that come with that. And you want to make sure she finds out the source. I see a lot of rice, fish, and I think even chicken now where arsenic is involved. So here's our 34-year-old female. And remember, she was fatigued, needs caffeine, tries to eat healthy, does eat fish and chicken for dinner. So she's getting protein, but sweets as well. So the need for energy, complaints of mild to moderate low back. These are all inflammatory looking findings for the low back and knees. And the bloating speaks to a need to support the gut. So again, the lipid peroxides, 8-OHDG, were somewhat elevated, although I think there was a mistake on that slide, so forgive me, because her slide did have a high 8-OHDG and elevated lipid peroxides in yellow. So that's what we actually had for this patient. And then the quinolinic acid, which is excitatory to the nervous system, reflects systemic inflammation and stress. The glyceric acid was high, magnesium need, B6 need, and then the elevated lactic acid and oxygenation. Maybe check for sleep apnea, for example, to see, is oxygen an issue? Is this part of the fatigue as well as the quinolinic acid and the oxidative stress? And the need for gut support based on the organic acids and the peptides. So antioxidant recommendations indicated glutathione perhaps, or glutathione direct supplementation or cofactors, anti-inflammatory support. Now, unfortunately, this patient didn't do an essential metabolic fatty acids add-on. Would have been nice to see what her omega-3 index looked like. Would have been nice to see whether her omega-6 anti-inflammatory DGLA was low as well. But without those, I might still consider omegas to try to help with that inflammation. I would check for the sleep apnea, the probiotic and digestive support, moderate needs, vitamin and mineral support is indicated, and looking for the sources of arsenic. And again, this was what we saw on the test. Actual findings, a lot of moderate antioxidant needs is what the algorithm saw, a lot of moderate B vitamin needs, some mineral needs, and some moderate digestive needs, and I would say address the inflammation as well. So that's the test. And if we have any questions, I'm happy to take them.
Thank you, Dr. Goldman. A lot of great information in there. It was really nice to see a few slides back with we have a couple questions that came in, just how this test differs from the Genova NutriVal. So again, you were able to lay that out. Anything you want to comment on that? Is it really just related mostly to the collection process?
Well, it's not so much a collection process, but what it is you're collecting. Because when you do just urine, you know, setting aside the essential metabolic fatty acid blood spot, that limits you to very specific findings that are great. But having blood, I think there's an advantage in that. There's an inconvenience in that. But I think the advantage of the NutriVal is you're going to have the option of a plasma amino acids, which gives you more of a longer-term view of how you're metabolizing protein, more like a 20 to 24-day window with plasma for the amino acids. If you choose that, you can still just do the first morning void if you want. And also things like glutathione, CoQ10, because you have that blood, you are able to because you're collecting blood, you're able to have those, whereas on a Metabolomix Plus, you're extrapolating based on other markers that need for glutathione, which is something you can certainly do. You do have those antioxidant recommendations, But I think that whereas in the Metabolomix Plus, you have the lipid peroxides, the 8-OHDG, but you still have that quinolinic acid to look at, for example. You still have the toxins, the MTBE, the styrofoam. So there's a lot there, the styrene. But it's nice to have with the blood the addition of glutathione and CoQ10 and the add-on option of vitamin D. So it depends on what you feel you need. The convenience of the Metabolomix Plus, though, is a great selling point because there really is so much information. And as I say, the patient gets everything shipped to them. They put it all in, they collect and they send it out. And there's no need to go get that blood collection. But you know, the NutriVal does have the advantage of the blood collection and the glutathione and the CoQ10.
Thank you. Is this available outside the U.S.? We do work with practitioners in Canada. Any issues with that?
Yes. No, that's not an issue.
Okay, great. Let's see, Dr. Sedano, I'm going to throw one out to you. What are some health conditions that would be helped by ordering a Metabolomix Plus test?
Yeah, hi, Doc. Great presentation. Yeah, some of the conditions that I see that this is helpful with, in my personal experience, is cardiovascular disease. Chronic fatigue would be another one. Certainly malabsorption. You have those analytes looking for dysbiosis, and also be aware of the diet as well can cause some of those analytes to be a little skewed, where Doc went over. Metabolic syndrome, insulin resistance, diabetes, all very, good clinical conditions to look at this test. And also, when you think about adrenal stress, how usually those individuals, they are so low on nutrients, that this is a good test to assess for that as well.
Thank you. Dr. Goldman, can you repeat what you said about giving glutathione versus precursors?
Oh boy, you're getting me into a very volatile situation. There's always been that debate. I've been at Genova for 16 years. I started when I was 12. And I always heard this debate because with glutathione, very often, if you give glutathione as glutathione, it was always indicated that it was poorly utilized because it had to get broken down and reassembled. And pyroglutamic acid is a big part of that. So a lot of people said, well, instead of giving the glutathione, it was advantageous to provide the precursors and let them make their own. I don't know if this is a settled score, by the way. For me, very often what I'm looking at is when I look at their Metabolomix Plus, do they have the precursors already? And if they do, and I think that they need more glutathione, I might just go with glutathione. And when I say precursors, we do measure cysteine, glycine, glutamine, functional needs for zinc and magnesium and B6. So if I'm seeing that those look pretty hardy based on my Metabolomix Plus, then I got to believe maybe they're not utilizing those precursors as effectively, and I might lean more in the direction of a glutathione, like a liposomal glutathione. There are companies now that make glutathione that's not liposomal. They claim it's better absorbed. The impression I get in speaking with practitioners over the years is that the absorption and utilization of the glutathione supplements has really improved over the years. So I think that's a useful bit of information as well.
Thank you. Does a person hold off on any supplements when testing, or is it best to test in the current protocol?
Well, the recommendation in the instructions is typically, I believe, 4 days without, if you feel they can do it. We're never going to encourage you to take them off of anything that you feel they need in order to run a test. But if you feel they can, to try to get more of a baseline view of things, measure of things, we recommend 4 days. Now, that doesn't mean you have to do that. There are some doctors that have patients that are just chronically going to be on certain supplements, and they know they're going to keep them on those supplements. And you might want to see, how do they look with the supplements? And I think that's valid, but I think the key there is you have to know when you're interpreting the test whether they did take the 4 days off or whether they were supplementing at the time. But as is always the case, it depends on what you find to be the most useful information. If you're trying to get more of a baseline, then the 4 days off, if you feel they can do that without issue. If you want to see what they look like on your protocol, I think that's valid, as long as I say you understand that when you're interpreting the test that they are supplementing at that time.
Thank you. All right, we're going to go with one more question and then we'll just wrap up with the rest of the evening. What functional tests are frequently ordered with abnormal metabolomics test results?
Well, in this test, for example, we talked about fatigue. And there are a number of tests depending on the patient, like an adrenal cortex stress profile is often with a 4-point cortisol and a morning DHEA. And you can also add on cortisol awakening response, CAR, with that. That's often something that people will follow up with. A stool analysis, I talked about the organic acids pointing us in a direction as far as dysbiosis, malabsorption, and yeast, but a GIFX 2200 is a very good place to go to get an overall feeling how things are. And there's also hormone testing. Hormonal testing is very significant. And one can do, if you have a patient that is cycling a rhythm or a rhythm plus that actually tracks a cycle over 28 days for the rhythm test based on the estradiol and the progesterone, but also has a testosterone reading. And the Rhythm Plus also includes an adrenal cortex stress profile and a comprehensive melatonin profile along with the rhythm. So those are the kinds of tests that we're seeing a lot of as follow-up. The adrenal cortex stress profile is very reasonable and gives you a great deal of information.
Thank you. Dr. Goldman, can you go to the next slide, please? So these are some Avexia wellness panels.
Yeah, Joanne, let me just jump in there.
Sure. Thanks.
I think they're paramount or just basic to order when you're looking at, say, a metabolomics test or a NutriVal test. Think about the effect of thyroid disease or hypothyroidism if the individual has anemia and so forth. So I'm one of these that I like to see the basic tests always first, the standard test, and then look at the functional test as a comparison. So especially if somebody's in adrenal fatigue, well, they may have hypothyroidism. That's where these panels with a functional health report can really shine. So don't forget to order basic lab tests. The other thing that I want to mention is that we learned several weeks ago that there are certain analytes on basic tests that can give you real good information about oxidative stress. If you were sticking with the Avexia webinar series, you may recall a GGT, uric acid, and total bilirubin. Very powerful basic analytes that will give you an idea of what is going on with oxidative stress in an individual. So I'll turn it back over to you.
Thanks, Dr. Sedano. Next slide. So I just want to mention we do have Ask the Doctor, Dr. Wayne Sedano, our Director of Clinical Support and Education, right from your Avexia portal on the left-hand side, a free email consultation for any lab interpretation, questions on clinical conditions, any question you want to answer right through your left-hand side of the portal. Email consultation is free, or you can sign up for a live consultation, which will connect you with Dr. Sedano via Zoom. And then the next slide. So now that we have learned about metabolomics, I would like to review how to order any testing mentioned in the presentation before concluding the webinar. First, you will need to log into your Avexia account and go to Avexia link ordering link, which is located in the left-hand column of the dashboard. Next, select or create a patient to assign the test to. Then select specialty labs. You will locate and select from the Genova Diagnostics test tab and go ahead and select Metabolomics from the menu. Finally, just complete the test order by clicking the green Place Order button. It is just that simple. And for our final slide, for any questions, please contact Avexia Diagnostics by email at info@avexiadiagnostics.com or by phone 5 days a week at our extended hours, 8 a.m. to 8 p.m. Eastern Standard Time. at 888-852-2723. Thank you, Dr. Goldman and Dr. Sedano, for this informative presentation. A recording of this webinar will be available to everybody that has signed up for this tonight in the next few days. If you do want the slide deck, please reach out to us via email, info@Avexia Diagnostics, and we will get that slide deck to you tomorrow. And thank you again for joining us for this webinar event. Until next time, from everyone at Avexia Diagnostics and Genova Diagnostics, stay healthy, stay safe, and we wish you all the best on your pathway to wellness. Good evening, everyone.